Now, dear students, I am going to explain what is the meaning of degeneracy and a duality. And degeneracy and a duality. See, the main point, what is the meaning of degeneracy? Degeneracy means it is nothing but a repeated terms. What is the meaning of repeated terms? For example, in simplex table, if you see here in the simplex table, just we calculated Cj basic variable solution values, some x1, x2, x3, s1, s2, s3, supposed to say that minimum ratio. Okay. Now take all given coefficients, enter into the simplex table. Everybody knows this one. In sometimes in minimum rows, suppose if you will get a minimum ratio 2 to 4, as per the definition, always give the first preference 2 for key row minimum positive value. But here is a minimum 2 positive values, which is the best, whether if I select this one or this one. So this type of points or arise any type of cosines, that is called as a degeneracy. You see, at the stage of improving the solution during the simplex procedure, minimum ratio determine the last column of the simplex table. Find the key row, like the any key row is there. For the key row, give the first preference to the maximum positive value. For key for key column, give the first maximum positive value. Key row, minimum positive value. If the minimum positive value both are repeated, select any one. That process is called as a degeneracy. But sometimes the ratio may not be unique. That is, the key element is not uniquely determine the first iteration. For the case 1, case 2, case 3, this value, one or more basic variable values corresponding columns becomes equal to 0. This cause of problems are called as a degeneracy. Sometimes in the key row also all values all are equal to 0, no positive. But according to the definition of the maximization, zeros are negatives, minimization zeros are positive. Sometimes all are zeros. So that type of problems are called as a degeneracy. Now come to the point of duality. What is the meaning of the duality? Duality, it means if any given problem, in LP problem, actually maximization, listen here, maximization is a different from minimization. That's all. Both are not same, both are not equal. But sometimes, if the problem is given in the maximization, I want a minimization solution. How to convert the minimization? Because maximization is one way, minimization is one way. Both are not same, both are not equal. But as a examiner, he wants a minimization solution with the help of maximization problem. Then we have to adopt one basic condition or basic concept. That concept is called as a duality. Okay, if for example, if the question is given maximization, supposed to say that maximization. So this is called as a primal. And if you convert with the help of some basic concept, maximization to minimization, this is called as a dual or duality. So one sum in one question, you have to calculate two answers, maximization and minimization. But what is the use of maximization, minimization means, take one problem, maximum problem, just leave it maximization way, go to the minimization condition, apply the minimization condition, you will get the answer. And the same answer, suppose if your answer is minimization is supposed to say that 100, same answer you will get in maximization 100 also. That is a speciality of the duality. So in examination point of view, please read the question 1 or 2 times. Solve the LP problem by simplex method, use duality. Then duality means basic concept is a different. So better to go to that way and this way. So previous questions are different, these questions are different. These questions are different. Today, I am going to teach you relationship between the primal and a dual solutions. What is the relationship? It means that if the problem is given directly, that part is called as a primal. So, in examination point of view, if the question is given, calculate the maximum value of z is equal to so and so. Now we have to calculate only maximum only. But with the help of that maximum, how, how to calculate the minimum value also? If you want to use, if you want to calculate the minimum value, we have to use another some techniques. The techniques all are coming in one part. That part is called as a dual problem. Now, how to convert these equations, I will show you. Uh, I will show you. Please come to this point. So, now, so the relationship between so relationship between primal and dual solutions. Primal and dual solutions. So, if the problem is given like this, suppose to say that maximize z is equal to, suppose to say that 8x1 plus 4x2 subject to constraint 15x1 plus 4x2 less than or equal to 650, 25x1 plus 6x2 less than or equal to 840, x1 comma x2 greater than or equal to 0, x1 x1 to 0. So let's come to the point. So x1 comma x2 greater than or equal to 0. Now this is and this point yes, converted. So the problem is given like this. So this is called as a primal stage. This point is called, this equation is called as a primal. So how to convert primal to, I mean to say that dual. Dual. Dual means only the thing is, in the primal point, all equations are contains x1 and x2. Now the dual means better to take another variables. So if the maximum case is given, then convert into opposite minimization. Z is equal to just the solution of these 650 and 840 equal to 650 y1 plus 840 y2. Next, subject to constraint. Subject to constraint. So take the first value. First value 15, 25. So here is a 15 y1 plus 25 y2 is a units of 8. It is a corresponding to the value 8. So that first you write down 8. Now for what are the first inequality equation symbol? Less than or equal to. So better to go to greater than or equal to. Next go to the second equation. 4 and 6. So that 4y1 plus 6y2. Then opposite value is a 4. So that write down 4. The second inequality equation less than or equal to, better to go to greater than or equal to. So y1 comma y2 greater than or equal to 0. So this is the, after that calculation is the secondary. Now today just we learn about something, how to convert the inequality equations of a primal to dual only. Suppose another example, suppose say z is equal to, suppose to say, so z is equal to I mean to say that maximize z is equal to 4x1 plus 2x2 plus 5x3. Now come to this point of this another. So that is subject to constraint. So 3x1 plus 4x2 plus 6x3 less than or equal to 10. So x1 plus 5x2 plus 7x3 less than or equal to 12. 2x1 plus 6x2 plus 2x3 less than or equal to 13. So x1 comma x2 comma x3 greater than or equal to 0. Now use the dual method. First, before applying the methodology, first you convert primal to dual. If the question is given maximization, opposite symbol is minimization. So this is the primal. So this point is called as a primal. First you write like this. So that is uh, take this and erase it, erase it, erase it. Now come to this point. Now come to this. Here is the minimize. So this is called as a, this point is called as a primal. First you write down primal. Okay. Now first you write down next dual, dual subject. So maximization is given. Write down minimization, minimization. Z is equal to. Here after inequality symbols 10, 12, 13, it convert into objective function values. 10y1 plus 12y2 plus 13y3. Next, subject to constraint. Take the first column values, column coefficients 3, 1, 2. So that 3y1 plus 1y2 plus 2y3. So what are the first column corresponding value? 4 in objective function. So first we write down 4 here. See the first symbol, first inequality symbol is given, first equation. So opposite symbol write down greater than or equal to. Go to the second column values 4, 5, 6 coefficients. So 4y1 plus 5y2 plus 6y3. The second equation opposite to 2. So that write down, first you write down 2. What are the second equation inequality? Less than or equal to. Better to go to greater than or equal to. Next third one 6, 7, 2. So 6y1 plus 7y2 plus 2y3. What are the third value? 5. So that write down 5. So that greater than or equal to. Next to y1 comma y2 comma y3 greater than or equal to 0. Now the first conversion is over. So this is dual. Once if you convert the dual, solvation is the second criteria. Forget about the how to solve the problem. Just I will explain the point to point. Only the thing is today just I am going to conversion of the given equation. Suppose the question is given like this one. So minimization, minimize, next, minimize. Z is equal to, supposed to say that 2x1 plus 4x2 plus 8x3. Next, subject to constraint. So that x1 plus 3x2 and plus 5x3. The minimization means always greater than or equal to. Supposed to say that 6. Next to 2x1 plus 4x2 plus 6x3 greater than or equal to 8. And the next one 3x1 plus 3x2 plus 7x3 greater than or equal to 9. The problem is given like this. So x1, x2, x3. Calculate maximum minimum value with the help of dual simplex method. Or in examination point of view, the problem is given like this. Find the value of variables x1, x2 values by the dual simplex method. Now the question, this is called as a primal process. This is called as a primal. Understand? Now come to the point of the dual. So how to convert the dual? Just setting is a dual. First you write down dual like this, dual. So if the question is given minimization, write down the maximization. That the maximization. What are the maximization? Z is equal to. Better to change the variables. Variables means 6, 8, 9. It is converted into 6y1 plus 8y2 plus 9y3. Next, subject to constraint. Take the first equation 1, 2, 3. So 1y1 plus 2y2 plus 3y3. So what are the first value here? First column corresponding to 2. Write down to first. Write down to the equation of the first greater than or is given. Better to write down less than or equal to. Next, go to the second column value 3, 4, 3. So 3y1 plus 4y2 plus 3y3. What are the second column corresponding to 4? Write down here 4. The second symbol is given greater than or equal to. Better to write down less than or equal to. Go to the third equation 5, 6, 7. So 5y1 so plus 6y2 plus 7y3, so less than or equal to 8. Next, y1 comma y2 comma y3 greater than or equal to 0. So the point is now how to convert the equations, I mean of primal to dual. So in examination pattern, now I'm going to solve simplex method of one problem with the help of a dual. Now come to this point.